Hello everyone. I am Divya. I am a data analyst currently working as a data science and business analytics intern at the Sparks Foundation. This video is made for the second task of my internship. In the previous video, I talked about supervised machine learning and demonstrated code for prediction of scores based on number of study hours. Supervised machine learning is a type of machine learning algorithm that uses dataset to make predictions. In today's video, I'm going to talk about unsupervised machine learning. So first, let's understand what is unsupervised machine learning. So it is an algorithm which is used to analyze and cluster unlabeled dataset. The objective here is to discover certain pattern in the dataset. Some practical examples are customer insights, clubbing customers based on their purchase behavior, demographics, and demand pattern across a certain location. To identify test markets for a new product, clustering also helps in analyzing best product market fit. In case of medical field, clustering has certain applications such as human genetic clustering, sequencing into gene families, building group of genes, and clustering organisms. The popular ML algorithms which are used for clustering are K-means algorithm and hierarchical clustering. K-means algorithm is based on Euclidean distance of data points from a center point. And hierarchical clustering is based on a different approach. In this case, each data point acts like a cluster at the beginning. Then the closest data points are merged together to become one cluster, and this goes on unless and until only one cluster is formed. In today's task, we are going to use K-means clustering algorithm for Iris dataset. So before deep diving into the coding part, I would like to just give some brief about the Iris dataset. So as the name suggests, this is the dataset of the Iris Flower family. It is a multivariate dataset. It is made famous by British statistician and biologist Ronald Fisher in his 1936 paper. The dataset contains 150 samples of flower, 50 samples of each of the three species, that is Setosa, versicolor, and virginica. The sepal length, sepal width, petal length, and petal width were measured by the same person on the same day at the same time by the same apparatus. So all the samples were collected on the same day when they were measured. Now let's go into the coding part and understand how we can implement and find out the optimum number of clusters by using K-means clustering. So as I said before, these are the 5 attributes which are available in the data set. Also, this data set is available in R-base and Python, a Python scikit-learn library. So I am using, so here while reading and understanding the data, I have imported certain important libraries, and this is the important command in case if you want to directly use the data set from the sklearn library. Once reading the data set, we can see that there are total 5 columns: sepal length, sepal width, petal length, petal width, and species. So basically the classes here are already defined. The shape is 150, 5. Obviously that there are 150 entries. Here we can understand that not a single value is 0. The data type of all the 4 measurements is in float and species is in object. These are the unique data values. And if we have to understand frequency distribution of species, 50 samples of each of the 3 species were collected. Now let's go to visualizing the data set. First of all, I have used scatter plot to understand the relation between sepal length and sepal width. So here it is clearly visible that Setosa has less length, I mean the sepal length is smaller and the sepal width is wide. So I would say the sepal is smaller in length and wider. And if we, however, we can see certain overlap in versicolor and virginica, sorry. And if we also plot scatter plot for petal width and petal length, we understand over here that both the parameters are smaller for setosa flower. However, it is in the middle range for versicolor and in the maximum range for virginica. Now let's go ahead and understand based on each of the four parameters that we have, let's understand the frequency of them. So for each species, I have plotted here dist plot based on which we can understand if the class is separable or not. So here we can see that based on petal length, setosa shows completely separate plot over here. However, the plots for versicolor and virginica are overlapped. Almost similar thing for petal width. Sepal length, all the three classes are getting overlapped on each other. And here we can see the extreme overlap, right? So sepal width is extreme overlap. So the insights are petal length will properly differentiate all the three classes and feature importance of petal length, and I think petal width is also good. So we will later on use this while we are building the model. Now let's move ahead for the modeling purpose. Let's first understand the steps in the k-means clustering. We have to choose the number of clusters k. We can randomly select centroids from the whole data set. We can assign all the points to the closest cluster centroid and then recompute centroids again for new clusters. And lastly, we have to repeat the step 3 and step 4 until the centroid converges. So first of all, in order to find the optimum number of clusters, we are going to consider all the four features, that is sepal length, sepal width, petal length and petal width. So I have assigned all the four columns to X data set over here. I have created a new data set. I have removed the species column, obviously because it is a categorical variable. Then implementing the k-means algorithm from sklearn.cluster, we have to import the k-means, otherwise it will not work. I have selected the range of 1 to 11 of these are the number of clusters that I have selected in the range of 1 to 11. Obviously here we know that the ideal cluster should be 3. So that's why I'm keeping the range from 1 to 11. That is, it will test for 1 to 10. It will take one cluster, two cluster, and it will continue going until the 10 clusters. So WCSS is nothing but the sum of square within this cluster. But in order to identify the optimum number of cluster, we have to use the elbow method. So elbow method is nothing but it basically plots all the number of clusters that we have taken. So here we have taken the range from 1 to 11. That's why on the x-axis we can see the numbers from 0 to 10. And on the y-axis, these are the WCSs, that is the distance calculated, right? So after analyzing the elbow method, over here we have to see that when the curve starts going like this, so here we can see that the optimum number of cluster is between 2 to 4 and we can assume it is at 3, right? It is right in the middle of 2 and 4. Now let's plot and understand if we take, let's say, number of cluster is equal to 3 and again carry out the k-means algorithm. Let's understand how it visualizes. So this is the visualization of the clusters. So in the red dots, we can see the 3 clusters. Over here, I think Setosa class has classified perfectly. The cluster is in the middle of it. Over here, we can see the versicolor and virginica have a certain overlap, right? Now here, as I have talked about previously, unlike supervised machine learning, we don't have splitted the data into train and test data. So we cannot actually evaluate the model. But in order to find out the accuracy and performance of the model, we can check uh, if some samples are classified properly or not. So as we already have the three species, by using the crosstab command here, we can understand the Setosa class as perfectly classified. All the 50 samples are classified perfectly. For versicolor, two samples are misclassified, and for virgin misclassified as basically virginica, and for virginica 14 samples are misclassified as versicolor. So the overlap here we have seen. So this is clear from this particular table as well. Now, as previously in while doing the data visualization, we understood that the three features are quite important. Let me get back to that particular graph over here, right? So petal length has uh, properly classified the Setosa species, however, shown overlap between the other two species. Similarly, for the petal width, sepal length, but the sepal width has shown a lot of misclassification here. So this feature is not able to linearly classify all the three species. So let's say what happens if we drop this particular feature and apply the modeling technique again. So I have taken only three features in consideration. Again, carrying out the same code of K-means algorithm. By the elbow method, we find that again the optimum number of clusters is 3. And by plotting it, we can see this graph. So almost similar, not much difference as such. But while this will give us the more clarification. Again, Setosa class has been linearly classified properly. Now, in case of versicolor, 5 data points have been misclassified, and virginica 13 data points has been misclassified. So I don't think this is the best model by dropping the last feature. Not much difference. Here there were 2 samples misclassified, and here there were 5 samples misclassified. However, here previously there are 14 samples and right now 13 samples. So not making much difference as such. I have also calculated by dropping the last feature and considering only sepal length and sepal width, but it has given terrible results. So I have not included that in this particular file. Yes, so based on all of this study, I have concluded that the data set can be divided into three clusters. The optimum number of clusters are three. One class, that is Setosa, is linearly separable from the other two classes, which is versicolor and virginica. And versicolor and virginica are going to show certain overlap. Thank you so much for watching this video. I hope you have understood everything. If you want to check this code, please visit the GitHub link below, given below. I will also post the link of my previous video where you can get the details of supervised machine learning. That was the example of a simple linear regression. Lastly, I thank the Sparks Foundation for giving me this opportunity. Because of this particular task, I have got the chance to revise unsupervised machine learning and also to revise all the theoretical details of K-means algorithm and hierarchical clustering. Thank you so much.